Okay, example 7, just like example 6, except now there is a man that has appeared. There is some sort of acrobat or something. He's walked out across the beam and he's stood in the middle. Right, obviously putting some pressure, so we're going to have to add his weight into the equation. But other than that, we're going to do exactly the same as we did in the first one. So let's start by having a little analysis of the diagram and add in all the forces that we know. We firstly have the fact that it is a uniform beam of mass 40 kilogram and length 5 meters. So that means that all of that weight from the 40 kilograms is going to be acting in the center of the beam. So this gives us a 40 kilograms, which is 40 G. Right? If they give you the mass, you've got to multiply it by G. And the distance from the end, or from this, I should say from C, is going to be 1.5, right? It's 2.5 because it's 5 meters, so it's 2.5 from each end. C is 1 meter from A, so it's 1.5 from C to there. That's the uniform beam and the weight of it. The man of mass 80 kilogram stands on the beam, so this is going to be 80 G coming down from him. It doesn't tell you exactly where he stands, it doesn't tell you any lengths, unfortunately. But it does tell you that the reaction of the magnitude at D is twice that of C. So if we refer to the one at C as R, then that would make the one at D, if it's twice as much, 2R. And I think that's everything we need to attempt this question. So, the first thing that we're going to do, I'd always suggest to do this first. Before we start dealing with moments, let's resolve vertically. You might not get an answer out straight away, right? It might not be any use, but you'll get an equation and you might be able to use that equation later on in the question, as we saw in example 6. So the two forces pushing up, stopping the beam from falling, are R and 2R. And the two forces pushing it down, causing the beam to have some difficulties, is the 40G, which is the weight of the beam itself, and the weight of this man, which is 80G. So actually we have got that 3R is 120G, which gives us that R is equal to 40G. Right? Or if you're desperate, you can times that by 9.8 to find out that it would be 392 newtons. That's the first bit, we've got the reaction. Unfortunately, that's not what the question's asking us. It's asking us for the distance AE. So we're trying to find out how far this man is away from the start. Right, that's what we're trying to find. Let's call this X, AE. Right, so the only other thing we've got to do, and this is going to be the same in every single one of these questions, even if you don't know how to start, resolve it vertically, then pick a pivot and take moments. It doesn't matter where you pivot it. Right? Wherever you pivot it, it will work. If you've got two unknowns, right, it might be good to pick the pivot at one of the unknown points so you can eliminate that, like we saw in example 6. In this case, it doesn't really matter. I am going to pick a pivot though, even though it doesn't matter. I'm going to take my pivot at C. The reason for this is going to make a little bit easier the calculation. In fact, no, let's not do it at C. Let's not do it at C. I'll do it at A. Right, because then I'm going to get the distance X is going to be part of my equation really nice and easily. We could have done it at C, but I'll do it at A. Often people find it easier to take a pivot at the end of one of these beams. And I know what R is, I know what 2R is, I've only got one unknown X, so wherever I take the pivot, it's going to work. So let's do moments about A. The great thing with a pivot at the end is it's really easy to see which are anti-clockwise and clockwise. Right, the R and the 2R are going to be turning it, if we think about it at the end, they're both going up, so they're turning it anti-clockwise, and the 40G and 80G are both turning it clockwise. So let's deal with the clockwise first. Right, so clockwise, I'm going to have two forces. I'm going to have 40G times, and then this is 2.5 from A. And then I'm going to have the second one, which is, sorry, I'll just work this out. This is 100G, right? Then the second one, which is going to be X, because we don't know exactly where that man stood, that's what we're trying to find out, times 80G. So let's just write it as 80gx. They're the two clockwise ones, right? They're pulling it down when we're taking the moment. And then in the opposite direction, pulling it up, we've got the first one, which is r. So r times 1, but we've just found out that r is 392 newtons. Right? Distance 1 and r. The 2r is the other one. And we've got that 2r is a distance of, well, if the whole thing is 5 meters and there's 1 meter here, that makes it 4 meters, right? So this is 8r, which is going to be a massive force, 8 times 392, which is 3,136 newtons, right? Now again, it's in equilibrium. It's not moving, right? We know that because it says it rests horizontally. If it wasn't resting, it might be moving, but the word rest gives it away. So if that is the case, then it means they have to be equal. All right? So clockwise and anti-clockwise, the blue ones were clockwise. This is the anti-clockwise when we do moments about A. We've got 100g plus 80gx is equal to 392 plus 3136. So when we rearrange, we get 80gx is going to be these two added together minus 100g. So we've got 392 plus 3136 minus 100 times 9.8, which is going to give us 2548. All we need to do is divide that by 80g. So 2548 divided by 80 times 9.8. That gives us 3.25. Right, and then check what x was back in the question. Yeah, we took x to be the distance A to E, which of course means, right, that we've got our question correct because that's the distance. X equals 3.25 meters. Don't leave it like that though. Make sure we actually answer the question. Distance AE is 3.25 meters. Okay. The key idea here, resolve vertically, then take moments about any point. All right. It might make sense to take moments about a point where there's a force you don't know, right, to eliminate that force if it's going to give you an equation with two unknowns, but it should really work at any point you take it at along the beam.